CBT Nuggets JNCIA series router interfaces. You know how sometimes you have to go through kind of a long introduction till you really get to the heart of the matter? Kind of like a classic rock song by, let's say, Pink Floyd or Rush, where there's 2 minutes of music and then finally the vocals kick in, or maybe that classic movie, The Wizard of Oz, where the house finally lands and she opens the door and there's the Technicolor Oz as she walks out. I'm finally in the movie. Or one more example. Remember Back to the Future when Marty McFly finally gets to Hill Valley in 1955 and he walks into the town square of Hill Valley? Wow, this movie's finally started. Well, this is the case here. The first 6 nuggets of this JNCIA series were really the introduction. Now we're going to get into router interfaces, and this is where we're really going to begin to start building our topology for our lab examples, and where you're really going to start to learn the meat and potatoes of ongoing configuration that you'll need as you go onto the job at Nugget Lab. So in this nugget, we have to understand the different interface types that we have on our Juniper router. We also want to understand different properties of the interface, and there's some clever things here with Juniper that are different. If you're coming from, let's say, a Cisco background, they're a little bit different. Okay, we're going to look at some configuration examples because there's lots of different types of interfaces besides Ethernet interfaces. We're going to look at some of those different physical interfaces and different configuration examples. Then we'll look at configuring interfaces on our lab router, which we're going to use in our upcoming labs and scenarios. And then, of course, we have to look at a network diagram to kind of what we're going to build on, and we'll review that network diagram, the one we're going to be using pretty much to the end of this series in our configuration scenarios. That's going to really set you up nicely as you walk on the job at Nugget Lab. Well, I'm looking at the duration counter here. I've introduced this particular nugget for about, almost 3 minutes now. So, you know what? Just like a classic rock song, let's finally get to the actual lyrics. Now, since our Juniper device, in this case our J2320 router, is going to be switching and routing traffic from an ingress interface to an egress interface, right, inbound to outbound, it would really help us to understand the different interfaces that we have and can have on our router. And obviously we're looking at the J series here, but when you move up into the higher level series like the MX series, for example, that we use for service providers and large enterprises, we of course are going to get more robust and more density on our routers. But again, let's keep it in line and keep it simple for our small Nugget Lab office here. Now, the first differentiation we have is to compare permanent interfaces versus transient interfaces. And just because an interface is permanent doesn't mean it's necessarily physical. Here's what I mean. If we look at this Juniper here, I'm looking at physical interfaces. I can see here is a console interface. That's permanent. Here is an auxiliary interface. That's permanent. Okay. This J2320 also has 1, 2, 3, 4 interfaces that are permanent. They're part of the chassis. And we know those are gigabit Ethernet 000, 001, 002, and 003. Right now, I'm connected to 000, and I'm doing my management on that particular interface. These other interfaces that are put into these slots, these modular slots, these are what we call transient interfaces. Why are they transient? Because you can remove them. You could move them from this device to another device. You could replace them. If you don't want to use these serial interfaces here, you could put in a couple of, let's say, DSL interfaces or fiber interfaces, right? It depends on your organization. It depends on your service provider. A wide variety of factors. Now, on a Junos router, there's a couple of other permanent interfaces that are management interfaces, okay? The first one is what we call FXP0. Okay, FXP0 is an OOB, or out-of-band management interface. In other words, this interface is not going to be in the same channel as production traffic that is flowing over other permanent or transient interfaces. Okay, it's actually connected directly to the router engine, and we can use this as out-of-band management access to our router. It also sends messages like SNMP, Simple Network Management Protocol. It sends messages known as traps, or you can send informs. These are newer, okay? So it'll send SNMP traps or informs. But remember, FXP0 is a out-of-band, non-transit interface. What does that mean? Well, traffic doesn't enter the interface and then go out one of the LAN or WAN interfaces. Also, you couldn't send traffic into one of these interfaces, one of these WAN interfaces or one of these LAN interfaces here or here, and then exit through the FXPO management interface. It doesn't work that way. Now on my J2320 and 2350, this is called FXP0. 0, of course, being the first and only instance. But on my switch, on my EX2200, this management interface is out of band is called ME0, or Management 0. And if you're going to be using routing protocols like we're going to be using OSPF later, got to be very careful. We don't want to have any routing in our routing table that actually is going to be sending traffic to the FXPO interface, okay? That'd be a situation called a black hole, okay? And that doesn't sound good, and you're right, it's not good. We don't want to black hole any traffic. Remember, it's a non-transit interface, but it's still a permanent interface because we can't change it. It's always present on your router. Now, there's also an interface for management called FXP1, and this is actually an interface that is fast Ethernet, or in my case gigabit, that is the interface between the routing engine and the packet forwarding engine. Now I talked about that earlier, and obviously there has to be some type of interface to send traffic from the routing engine to the packet forwarding engine. Got to have it, okay? So this is a logical interface. It's not ever configured, and we really only find it on the M and T series router, okay? It's not on my J series platform. You'll learn more about that when we go into the JNCIS and JNCIP. When you start up your router, okay, initially, remember, we crank that puppy up and we get to that root prompt, right? Well, we do have what are called some pseudo interfaces. PSEUDO. Pseudo, makeshift, quasi, ersatz interfaces. And these pseudo interfaces are also permanent. They're there at startup. The first one we should know about is LO0. That's loopback 0. So you have this initial first instance of a loopback interface, and that's different than other platforms where you have to actually create your first loopback interface. Not on my Junos router, okay? And this particular loopback interface is not connected to a physical interface. It's usually a stable address that we configure on our router. Let's say something like 1.1.1.1/32. This interface never goes down, right? It's not a physical interface, so it can't go bad. It's always up. So we can use this to source and receive management traffic, as well as routing protocols like OSPF, for example. We can also use this loopback interface, as we're going to see later on, with firewall filters. It allows us to protect our routing engines from denial of service attacks and other reconnaissance attacks that would be directed towards our device. Now, there's several of these pseudo interfaces, and we'll learn more about them later. I only want to mention one more right now. It's called DSC. This is the discard interface, and we use this to what we call discard packets silently. Silently, let me jot this down in parentheses. A silent discard means we're not going to send some type of ICMP error message or any type of error message back to the sender. This is also used to protect against denial of service attacks, okay? So this discard interface, by the way, this is also like on other systems like Cisco, for example, calls this the null zero interface or the bit bucket. It's basically where packets go to die, okay? On our Junos router, it's the DSC, the discard interface. Okay, so we've got permanent interfaces, like the physical interfaces that are part of the chassis, manufactured part of the chassis, and we've got permanent ones like Loopback 0 and DSC that are pseudo interfaces, okay? But they're still permanent. Let's talk about transient interfaces. These again are ones that a user, an administrator, can add or replace or move or whatever, okay? These are typically on removable cards, and these cards are referred to as PICs or PIMs. A PIM is a physical interface module, and this is providing additional interfaces for different scenarios on your router. So for example, we might want to provide transient interfaces for fast Ethernet to add additional fast Ethernet functionality, or gigabit Ethernet functionality, adding these 16 ports here, for example, these 16 gigabit ports. But you may also need them for, let's say, ATM connections, asynchronous transport mode or transfer mode, fiber. Maybe you need SONET interfaces for fiber connections to other routers in your campus or to your service provider. Maybe you want T1 interfaces or E1 interfaces if you're in Europe. Maybe you've got a DSL interface you need on your router to connect to your service provider, right? So different types of transient interfaces that you can use on a as-needed basis, all right? Okay, here's Poderosa, and I'm telnetting in between my two routers, my two Juniper routers, 2350 here and 2320 there. Not much changes, just this third number. So here's the 2350. I'm going to do the show interfaces terse command, which is really a good one to know. And there's a bunch of interfaces here, and we're not going to go into all of these now. We'll learn more about these as we progress farther along, but I want to focus on, here's a very popular interface, okay, the GE or Gigabit Ethernet interface. And I want to talk about this interface naming here, okay. By the way, here's our discard interface, or pseudo interface. We've got our loopback interface. I mentioned that's a pseudo interface. My physical interfaces that are permanent are Gigabit Ethernet 000, 001, 002, and 003. These are what we'll be configuring here upcoming. Now, this one right here, let's take a look at this GE. This is the media type, okay? So there's lots of media type, by the way, okay? This is one of the most common, but I could have 10 gigabit would be XE. If it's serial interfaces, it would be SE, right? If it's T1, it would be a T1. If it's T3, it's T3. If it's ATM, it's AT. If it's ISDN, it would be BR. So there's lots of different types of interfaces depending upon whether you have transient cards installed in this router. So the first thing here is the media type. So GE Gigabit Ethernet, okay, or 1000 megabits per second. This first number is what we call the chassis slot number. Now, on my J router here, my 2350, 2320, I only have one chassis. But on the higher end devices, you may have multiple chassis. And each one of these devices, by the way, kind of has their own naming scheme in the sense of whether they're going to go left to right or right to left or horizontally or vertically. And you have to make sure that you understand that with the documentation that comes with your device. But the first one is the chassis slot number. Next we have what's called the PIC slot number, okay? So, and by the way, I've only got one PIC slot, PIC slot, on this 2350 or 2320. So I'm going to have basically chassis 0, which is the first instance, PIC slot 0, which is the first instance, and then the port number. So I've got 00 port 0, which is the first, then port 1, then port 2, and then port 3. Those are the 4 physical attached Gigabit Ethernet ports on my 2350 and 2320 chassis. Now, if I were to add other transient interfaces for things like DSL or T1 or SONET fiber cards or whatever, and initialize those cards, in other words, restart my router, those interfaces would show up here as well. okay, along with a lot of these other built-in logical interfaces that we'll learn more about as we progress farther and farther along, okay. So I really want to focus on some of the kind of the fundamental basics here of what we need. As we can see, I've already configured gigabit 000, and we're going to talk about what's going on here with the .0 as we get into the configuration. We can also see it's family INET, okay, or it's the protocol family IPv4, basically, so INET. Okay, on the 2320, let's go ahead and do a show interfaces, and we'll say gig E000 on this router. Now, something to understand also is that there's different types of properties for an interface. So for gig E000, I can have physical properties and I can have logical properties. So for example, some of the physical properties of gig E000 are its link level type, it's Ethernet, okay, it's an Ethernet interface. The MTU, the maximum transmission unit of 1514 bytes, okay, full duplex, the speed of 1 gigabit per second or 1000 megabits per second. Those are what we call physical properties. And those are the most, common physical properties. But if we move down here and click, we got more showing up. Down here, we're going to see some of the logical properties. Well, a very common logical property is the protocol family. So protocol, this is the INET family, protocol INET. So that's the most common, okay? That means you're going to be doing basically TCP/IP version 4, okay? So it's the INET family. That's a logical property of the interface, which could be modified, okay? Because other families would be, let's say, INET 6, which is IPv6. There's also the MPLS family for multi-protocol label switching, which I might do on this interface. I might even do ISIS on this interface, so it would be family ISO. It just so happens I'm going to be doing IP version 4 primarily on this interface. Something else is the logical IP address. So this local here, it has the IP address of 192.168.3.5. That is the logical IP version 4 address. Let me bring this out a little bit. We can also see the directed broadcast on the 192.168.3 network is 255. So if you want to send a packet to everybody on this subnet, that's the address to do it to. Now there's other logical addresses or other logical properties that this interface gig E000 could have. For example, if I'm going to have VLANs on this particular interface, the VLAN ID, that logical number, let's say VLAN 10 or VLAN 20, that's a logical property. If I'm going to be doing frame relay on this interface gigabit 00, okay, if I'm going to be doing frame relay, well, the DLCI number, DLCI, that's a logical property. Or ATM also has its own circuit numbers, okay, so those are logical properties. Now if I do the show interfaces terse, oops, let's do that again, terse, one thing we're going to notice right here on gigabit 00 is this .0. Okay, what is that? That's a very important value. That's the unit number. Now we've already seen this. When I configured an interface earlier on in this Nugget series, I configured gig E000 and I said unit 0. Okay, this unit 0 here, this unit is actually what kind of contains, it's kind of a placeholder for these logical properties that we looked at down here, right? So this unit number 0 is what kind of holds the IP address, for example, and the fact that it's going to be family INET, okay? So we have to have that kind of placeholder. This is one thing that makes Juniper different than things like Cisco, okay? Every interface, every Ethernet interface has to have a, quote, sub-interface by default, okay? In Cisco, sub-interfaces are optional, but not the case here. I have to have this unit number, at least unit 0. We'll see this when we configure our interfaces, and I'll return to that concept. Now, if this is a point-to-point interface, then I have to have unit 0. The logical unit number must be 0, okay? Or if this is a non-VLAN interface, and this is. It doesn't have a VLAN tag on it, okay? If it's non-VLAN tagged or encapsulating VLAN traffic, then if it's not a VLAN interface, it's got to be 0, okay? So remember that for the exam, right? If it's a point-to-point circuit or a non-VLAN tagged Ethernet, which is what this is, then it must be 0, okay? The unit number must be 0. So keep that in mind, some really important information as we get closer and closer here to setting up our lab environment. Now before I do this, I want to show you some examples of other interface cards that we could add to our J-Series router, and just a quick little blurb of the type of configuration we'd have to do to set those up. Here's some common transient interfaces or modules. For example, here's a serial interface module. You can see this 2350 actually has this module right here, and you could configure this for PPP, very common. You could also configure this for frame relay. The types of things you would do as far as configuration goes, if it's PPP, you'd have to figure out which one of these interfaces is going to be the clocking interface, the DCE, and which one of these is the DTE. If this were frame relay, you'd have to make sure that you added to the configuration encapsulation frame relay, also possibly getting Dulce numbers from your service provider on that interface. You could also use this module, which is the ADSL module, for example, for a small office or a branch office. If you're dealing with an ADSL module, you'll be using PPPoE or PPP over Ethernet. So you'll be getting some information from your service provider to help configure that PPPoE configuration as well. It could be PPPoE over ATM if it's a business connection, for example, to the central office of your service provider. Down here you can see an older ISDN cards. We don't really use that much anymore, maybe in rural areas. Here's a T1 card. Often a T1 card will use Cisco's HDLC encapsulation. No real big configuration there other than the command encap Cisco HDLC. So you can see these are different modular choices we can add to these slots on these modular routers, these J-Series routers, to add functionality for WAN connectivity in different situations, suburban, rural, metropolitan areas, depending upon the type of connectivity you need to your service provider. We can also add to this area here more port density, as we can see here, and we can add more gig E ports. And of course, you want to look at the documentation that comes with your router to figure out which chassis and which slot, so you can identify whether it's gig E0, 0, and then port whatever, or gig E1, 0, and then port whatever. Okay, so, and of course when you purchase your device, you'll get that documentation, and it'll allow you to go and make sure that you understand exactly what you're configuring. Also, when you do a show interfaces terse command, these initialized modules will show up in that output. Alright, let's go ahead and configure the gig E interfaces on my J2320 router right here. Now this is the topology we're going to be working with throughout this Nugget series, and actually even into the JNCIS series. And you're probably wondering, well, okay, I've got some icons here for Juniper routers, but what's up with these routers down here? Well, these are Cisco routers, okay? So I've got two Juniper routers, and I've got two Cisco routers, CR1 and CR2. These are both integrated services routers from Cisco. Now you might be asking, why do I have those? Well, really my reasons are threefold. As we progress farther through, obviously on the job here at Nugget Lab, we want to know the differences between Cisco and Juniper. But more importantly, one of the most important tasks you have to master as a Juniper professional is to be able to migrate a Cisco network to a Juniper network. That's one of the most common things that happens nowadays. So we have to look first at having connectivity, let's say with the RIP version 2 or OSPF, to our Juniper routers and our Cisco routers, and then once we get that connectivity, that dynamic routing relationship, we start to migrate from Cisco devices devices to Juniper devices. This is an ongoing task, something that we're going to be doing from now on. And so it's not that uncommon or that wild to see some Cisco routers in the topology. Now, we're not going to be configuring CR1 and CR2, but we are going to be connecting to them, okay? Now, here's what I have going on, like a cooking show, right? My J2350 is already set up. It's already cooked, okay? And my J2320, we're going to go ahead, you and I, in preparation for our job over here at Nugget Lab, we're going to go ahead and configure that router. Now, what I want to do is this. I want to take this very incrementally, okay, instead of just jumping into this whole configuration, because we're just now getting into interfaces. So here's what we're going to do. We have this link between these two routers, okay, and it is on gigabit 002 on both routers. So we have a link, a direct link, and this is on network 172.20.66/30, which means basically we've only got 4 addresses, okay? .0 is the network. We've got .1 and .2, and .3 would be the directed broadcast on this network here, on this 66.0/30 network. So I'm going to focus on just this link right here and connecting this. So we'll go over and look at J2350 first and see the existing configuration, and then we'll configure J2320 and we'll start with that one. And we're also going to talk about some of the things that are important, like for example the fact that you can have multiple IP addresses on a single interface, also the ability to VLAN tag an interface like we've done down here on gigabit 001 on both of these routers. You can see the .100 there means unit 100 and unit 200. Well, these are going to be VLAN tagged, and we're going to have VLANs going to these Cisco routers. Pretty cool, huh? Well, we want to learn that as well. So let's go ahead and take a look at our 2350 real quick. I just remembered one thing I want to show you before I leave here. Down here, this is my management station. This is the station that I'm on right now recording this nugget. It's also my network management station. It's at 192.168.3.10/24. So it's on the 3.0 network. Now, you might be wondering, what happened to gigabit 000? Well, that's the management network that I'm dealing with, my management VLAN, we could call it that. So on my 2320, gig E000 and gig E000 on my 2350, these are both on the 192.168.3 network. Okay, so to be specific, the 2320 is at 3.4 and the 2350 is at, I'm sorry, the 2320. So the 2320 is at 168.3.5 and the 2350 is at 168.3.4. Okay, so those interfaces are being dedicated to actually accessing those devices, in my case through Poderosa with Telnet connections. Okay, so I want to keep in mind that's what's going on also kind of under the hood. Okay, on the 2350, let's go ahead and first get into configuration mode, and I'm going to do a commit confirmed. And let's do it for, how about 10 minutes? Because I don't really want to confirm any of the changes I'm going to make. So I'm going to mess around here in the 2350. I'm not going to commit it. So after 10 minutes, it's just not going to save my changes. I showed you that earlier. Kind of a fun thing to do, actually, if you're going to be messing around. So let's just first take a look at this. I can do a show interfaces, and how about a show interfaces terse command? Do a run show interfaces terse command. Okay, you got to do that run there if you're in configuration mode, run to do a show command that you would normally do in operational mode. Okay, so you can see I pretty much cooked this. I want to focus on this interface right here. That's the one I mentioned in the topology. Okay, 002 unit 0. Okay, so it's the only logical interface, sub-interface, you want to call it that. It's family INET, and we assign the address 172.20.66.2. Okay, so I already did that. And I want to just make sure and confirm that. Now I can also, let's Control C, I could also do a run show interfaces and do just that interface, okay, gig E002 terse, and you can just do a quick take a look at this and say, okay, there's what I have assigned to it. All right. Now, what I want to show you here is the fact that you can actually assign more than one IP address, okay, to an interface. In this case, to unit 0 on GigE002. So let's go ahead and do that. Let's say we'll do an edit interfaces, and we're going to say set GigE002. Again, what was this? It was unit 0, wasn't it? Okay, now I can say unit 0, right? That's my sub-interface or my unit, or I could say 002.0. That's the same thing. Either one of those will work, right? Now, what family is it in? Okay, I have to tell it what family it's in, and we can see usually it's going to be family INET. And as far as we're concerned here at the JNCIA level, it's always going to be family INET. But it could be, you know, INET 6 if it's ISIS or ISIS. You could use family ISO or family multi-protocol label switching, MPLS. We're always going to be doing family INET, so we'll stick with that. And I'm going to do an address. And I'm going to say, let's say 172.16.100.2/24. We'll add that on there. Now, if we do that same command again, where we do a run show interfaces GigE002 terse, it's going to show us, oh, we have to commit that first, okay? Let's go ahead and commit that, and then we'll roll it back. Okay, so now we'll do the terse command, and now we can see that on GigE002 unit 0 we have two IP addresses, okay, 172.16.100.2/24 and 172.20.66.2/30. And by the way, this is often a troubleshooting issue, okay, that we run into. You accidentally are going to assign another IP address to an interface, because unlike other platforms, it's not going to bark at you if you try to add another IP address on it, okay? If we do a run show interfaces GigE002, what we're going to see here is this. Physical interface, it's enabled, link is up, okay? If we come down here though, look at these addresses. Notice that we've got 172.16.100/24 is preferred and is primary. And then we have 172.20.66/30 that is preferred for, obviously, for that network. Now, why do we have a primary address? Okay, if you only have one address on here, it would be, you know, the original one, which this was, would be preferred and would be primary. Okay, why do we have a primary address? Well, every unit can only have a single primary address, and we could have multiple preferred addresses. We see here we've got two preferred addresses, right? This one's preferred and this one's preferred. Okay, two preferred addresses, but only one primary. Why do we have a primary address? Well, that's the one that's used to source local packets out of this interface that's destined for a remote network. So any packet that's sourced in this interface going to a remote network is going to be sourced from the primary 172.16.100.2. Actually, I should go ahead and choose the actual address here. I've been choosing the network. Okay, for the sake of time, I'm going to jump back over to my 2320. I need to configure this thing for our topology. I went ahead and did a rollback 1 over on my 2350 to get that back to its base configuration that I showed you is kind of already cooked. Now, what I want to do is show you this. Here's the topology, just a little bit of it from the 2320 standpoint, okay? So what we have to do, since all we have configured on this 2320 so far is GigE000, right? That's the one that connects to my management station down there. And that's on 192.168.3.0/24 network. And we'll see that a little bit later on. So I need to configure really 4 interfaces here. I need to configure the loopback interface. We're going to need that interface to kind of identify this Juniper router with dynamic routing protocols, for example, and other things. Then we want to go ahead and configure Gigabit 002, which is the point-to-point link to the other Juniper router, the 2350. And I've got this one, the Gigabit 003, which goes up to the Internet Cloud. And then I'm going to come down here and I'm going to configure on Gigabit 001. I'm going to configure this as a VLAN interface, and I'm going to place unit 100 as VLAN 100, give it an ID of 100 and an IP address of 172.20.100.1 for a couple of reasons. I'm going to use this kind of VLAN connection to this Cisco router later on, but I also want to show you how to configure a interface to have a VLAN ID on it, okay, or to make a unit have a VLAN. So let's go ahead and start out here. I'll minimize this and then bring it back up. Let's go ahead and configure our loopback interface first. So we're in operational mode, so we're going to do edit, and we're going to edit interface. Let's just go ahead and do an edit interfaces and get into that mode. You can see in the square brackets that we're in the edit interfaces mode. By the way, if you ever want to get back up to the top of the topology, just put in the keyword top and it gets you back up to the edit, okay? So let's do that again, edit interfaces. So we want to set loopback 0, and again this is going to be unit 0, and the family is going to be family INET or IP version 4, and the address you want to assign to this based on the topology is 192.168.1.1 with a 32-bit mask, okay? So there's our loopback interface. Now let's go ahead and set the gigabit 003 interface. This 003 interface is going to have an address of 172.18.1.2/30. Remember, /30 is the same thing as a subnet mask of 255.255.255.252. Okay, so let's go ahead and set that interface. So we're going to say set gigabit Ethernet 003. Remember, we haven't committed this yet. And we know it's unit 0. I could type in unit 0. I could just do .0. Same thing. It's also of the family INET. And the address is 172.18.1.2/30. Next, let's do that link over to 2350. Okay? So that's going to be setting gigabit. Oh, by the way, if you do set and a question mark, it shows you, it'll give you a list of the interfaces that you can set. So we're going to set gig E 002 this time, and we'll just go ahead and do unit. And by the way, question mark tells you what number do we want? Logical unit number, okay? Unit 0, and then this is also family INET, hitting the space bar here, and the address. Looking at the topology, let's look at the topology again. Right here is 66.1/30. Okay, so let's go ahead and 172.20.66.1/30. Now what we want to do is this. We're going to go down to this interface. Let me get the topology again. We're going to go back down to here to gigabit 001. This one right here, we're going to actually configure this gigabit interface for VLAN tagging, which means we can actually create units and assign VLAN identifiers to them. Okay, those are layer 2 broadcast domains. So we have to do that first. So we'll set it up for VLAN tagging, then we'll give it a VLAN ID, right? And usually the unit number and the VLAN identifier are going to be the same. So in our case, it's going to be unit 100, and then the VLAN ID will also be 100. Okay, and so down here, my Cisco device, this interface will also have to be configured for VLAN 100 as well. So we're going to set gig E 001, and we're going to say .100. Okay. So, or we could say unit 100, that'll work as well. Actually, we don't want to do that yet. We just want to say 001, we want to configure it for VLAN tagging, okay? So we have to turn that on first. So now we can tag it. So now I'll just hit the up arrow and say VLAN tagging, and now we can say, we'll say unit, okay, not unt, but unit. Like I said, it's unit 100. It'll also be VLAN 100, VLAN ID, and then 100. Do you have to make the unit number and the VLAN ID number match? No, you don't, but it's a good idea, and it's a great way to do it in the beginning, okay? Now at this point, I've got this gigabit 001 unit 100 or logical subinterface 100 tagged as a member of VLAN 100. Okay, so at this point, if it's connected to a switch or another layer 3 device, it can only communicate with other devices in that same VLAN or that same broadcast domain, right? I do want to go ahead and assign an IP address to it though. So we're going to say let's set gig E001, and we'll say .100 this time. We'll be clever and say it's family inet, and the address going by the topology is 172.20.100.1, and it's /24, 24-bit mask this time. Okay, I'm going to go ahead and say I want to commit it and quit, and it's going to commit it, and then it's going to go back to operational mode, and now we can say show interfaces terse. And now we're going to see we've got, this is obviously my management interface, but we can also see we've got gigabit 001 unit 100, that's our VLAN 100 interface, family inet, and there's the address we just assigned to it. Here's gigabit 002 unit 0 with address 66.1, that's the connection over to the 2350, and then I've got 003.0 unit 0 with 1.2/30, that goes up to the basically the internet cloud. So that's what I wanted to do to match this topology that you can see here. I've configured all my interfaces. Now, once we have our interfaces going, we can start looking at connectivity. Now, the best way to focus on connectivity is to think about what types of routing do I want to have to my other devices. And as a matter of fact, if I go ahead and I say show route right now, I've actually got a static route configured, and I've also got a bunch of other information here. All these direct and local entries have been placed in my inet 0 routing table. We've got several routing tables, by the way. We can also create our own routing tables. For example, if you're a service provider, you could create a routing table or an instance of a routing table for each one of your customers. Okay, and so I've got all these entries now that are in place in my routing table, direct and local entries based on these interfaces that I've configured. I've also got a static route that I created, and I created this static route so that, and you can see that it's to 3.10. I created this static route so I can successfully ping that workstation. So if I do ping 192.168.3.10, I can count 5. Forgot about that. We'll do 5 pings, or 5 ICMP echo request echo responses. Now remember, if I do a ping, remember that I would have to do bypass routing if I didn't have, let's go back up here, if I didn't have this entry in my routing table here, okay? If I didn't have this static to my management station, I'd have to use that bypass routing keyword, okay? Because I don't have an entry in the routing table. As a matter of fact, on the 2350, I don't have any static routes configured, so if I wanted to ping my management station from 2350, I'd have to use that bypass routing keyword along with that. But I don't want to get any deeper into routing, okay? We can just see that we've got a bunch of default entries that are added once we configured our interfaces, and now we're going to start looking at, in the next nugget, we're going to start talking about and learning about routing as well as configuring static routes on our 2320 and 2350 router, and then testing connectivity between those devices. Sound good? Alright, we're into the good stuff now. In this nugget of the JNCIA series on router interfaces, we covered 5 main topics. Talked about the interface types and interface properties, looked at some configuration examples. Both on my 2350 and on my 2320, I configured that router, getting it ready for our lab, configured basically a loopback interface and 3 other interfaces, including a VLAN interface on one of them. And then along the way, we looked at the network diagram and we reviewed that, and we'll be coming back to that throughout this particular nugget series as we use that topology over and over again to help us prepare for that entry into Nugget Lab and our on-the-job experience. Well, I hope this CPT Nugget has been informative for you. I want to thank you for viewing.